G'day. Welcome to Crystal Clear Mathematics, where it is easier than you think. I'm Graham Henderson. In my previous two videos, we've covered four basic principles. The first is that parabolas and quadratic equations are connected. Because of the way that a parabola is designed or constructed in geometry, when we place it on a coordinate graph, the formula, the equation we get for it, turns out to be a quadratic equation. So there's a link between the two. We've learned that parabolas are symmetrical about an axis. We've learned also, the third thing, that their structure is, because it's based on perfect squares, is also based on odd numbers, and we're able to use a series of odd numbers to construct a parabola quite quickly. And the final thing we learned was that if a parabola isn't centered or isn't passing through the origin, isn't centered on the origin, that it's located somewhere else, there's a very simple way of finding its vertex, given that you're given the equation in a particular form. Now, if you're unfamiliar with any of those four principles, you might like to go and look at the previous two videos. In this video, we're going to look at the four basic requirements of analysing a parabola in its normal state. This is the state that most students learn in their middle high school years. So let's have a quick look. First of all, when parabolas are graphed, they come in a variety of positions and orientations. Some parabolas are oriented pointing upwards, and some are oriented pointing downwards. Some don't actually reach the axis, so they're always below, or sometimes always above the axis. And they can, of course, move sideways as well. So their position is rather open, or up for grabs, we would say in Australia. Not only that, we will learn later that you can in fact have parabolas turned on their side. I'll draw another graph for that. You can have parabolas on their side. We will encounter these in later videos. And you can in fact rotate them as well. So you can have parabolas sitting at an angle. Now, this is rather more advanced, and I may get around to sharing with you how to use matrices in trigonometry to rotate parabolas and to actually calculate the equations for them. But this is certainly not done in New South Wales schools here in Australia. Not anymore. It used to be when I was at school. But certainly these other ones will be discussed. And what is it about them that is interesting to mathematicians? Well, apart from the pure abstract fascination of how algebra and pictures and graphs all fit together, parabolas are extremely useful. Any time where you have two things multiplied together in the real world, for example areas, length times breadth, you have the potential to get a parabola, because you're going to get an equation that potentially has squares in it. Something times something. And so, for example, you may get an equation like this where you're calculating an area against a particular dimension. Let's just call it L for length. This one here, for example, might be height or altitude, and it could be length or time. So as time progresses, something might have been tossed. If this is ground level, where the height is 0, something might have moved up and then fallen back down to the ground. Instead of time, it could be a horizontal displacement. There are all sorts of properties in the real world where parabolas are involved. And you may know that on the surface of the Earth, if you throw a ball or something, as neglecting air resistance, that it will travel in a parabolic arc. So parabolas help us analyse and understand a lot of things in the real world. What is it that mathematicians are particularly interested in? Well, like most of us, we'd be very interested, for example, in the position of the very tip. For example, if we're throwing a ball, we might be curious just how high we can throw it, and that would be the maximum height at this point. This, of course, remember, we name this the vertex. It just means the tip. I should also say that the plural is vertices, not vertexes or anything else. I should spell that V-E-R-T-I-C-E-S. That's when you have more than one of them. So here we have a vertex and a vertex and a vertex. So we have vertices. But we'll be curious about that. If this was an area, we might be looking for a minimum area. Or a maximum something else. But we're curious about these points. So the first thing, actually, in the grand scheme of things, I'm going to put it last, we're interested in the vertex. The third thing we're interested in is because you might remember that we've discussed the principle that parabolas are symmetrical, they all have an axis. That was badly drawn. This one through here. The axis always goes through the vertex. So we're often curious about where the axis is. That helps us to draw the parabola and to analyse it in a variety of ways. For example, if this was horizontal displacement and we knew where the axis was, then where we threw the ball from is just as far from this position as where it lands. So its maximum height will be exactly halfway between. So the axis is of interest. And because it's drawn on grid paper and we're comparing two variables, we're often interested in the positions where the parabola cuts each axis, this axis, and we've already discussed here. Here, for example, we'll be talking where the ball leaves the ground, here where it hits again. Here, if we had a wall, for example, we might want to know where the ball hits the wall, and later on you develop skills to work out with what velocity and at what angle and all sorts of things like that. But we're curious about these positions, where a graph cuts the axes, and we've got particular names for these. The one where it cuts the y-axis we call the y-intercept. And the ones where it cuts the x-axis we call the x-intercepts, which correspond to what we call the roots, or sometimes the zeros of the quadratic equation. Now, these are the four things that mathematicians are interested in. Let's go through them again in red. And this is actually the order I get my students to calculate them in, largely because this one is the easiest, usually, and so forth. But that's not always the case, and we'll discuss why and how to get around that. But the y-intercept would be this position, where the parabola cuts the y-axis. The x-intercept would be these. The axis here, and the vertex, of course, right on the tip where the axis is. They're the four objects we're looking for, and the four things that mathematicians most want to know about a parabola. Not some point on the curve here. Occasionally we do want to know that, but these points are of particular interest, and they're the ones we learn about in school. So, how do we find each of these? Well, that's a very good question. Let's have a look. Here we have an equation of a typical kind of quadratic equation. I've chosen quite a fairly simple one, but not the simplest. And it's in what we call the general form. Now, when you see a parabola or a quadratic equation written in the form something x squared plus something x plus some constant, some number on the end, it's what we call the general form. You'll see mathematics books will often have this. Y equals ax squared plus bx plus c. This is the general form. And the a, b and the c are meant to represent the numbers we have in front. This would be 1x squared plus 2x and minus 3. So a would be 1, b would be 2 and c would be minus 3. And there are other forms, and we're going to discover other forms for the parabola. In fact, that represent the parabola. In fact, we used a different form in the previous video called the completed square form, and we're going to revisit that in time. But this is the common one that students are introduced to first in schools, and it's particularly good at finding the very first of these 4 items that mathematicians want to know. I'm going to use headings. I like to use headings. So the first one, we're finding the y-intercept. Helps if I can spell, doesn't it? Dear oh dear. Intercept. And how do we find the y-intercept on a graph? Well, it's where the graph cuts this y-axis. Now at this stage, if you're new to parabolas, you don't know whether it's over here or over here or over here. So the parabola, or up here or wherever it is, we're going to discover that. But there's something about the y-axis that is useful to us, and that is that although the y value changes, and that's why it's called the y-axis, y is 1, 2, 3, 4 and so on, the x value is always 0. If I asked you to plot this point, this is the point 0, 0. This point is the 0, 1, 0, 2, 0, 3, 0, 4, and the first value is always 0. You might remember when we write coordinates, we write them like this. And that's the x and the y value. And when the x value is 0, it means don't move left or right on the x-axis. And when the y value is 2, it means go up 2. So that would be that point, 0, 2. So since x equals 0 all the time on the y-axis, that's the equation of the y-axis. And it means that if I want to find where this equation meets this axis, I put the value x equals 0 in here and it tells me. Now, when I'm teaching my students, every time we find these 4 items on a parabola, I get them to also write how they're going to do it. So to find the y-intercept, we're going to substitute x equals 0. Let's do exactly that. Y equals 0 squared plus 2 lots of 0 minus 3. Now of course you know 0 squared is 0, 2 times 0 is 0, and we add this all up, I'll actually write it out in full, is minus 3. Now honestly, you don't have to do this very often before you realise that the y-intercept is always this number on the end. Because when you put 0 here and 0 here, it really does not matter what number's in front. You can have 5,000x squared minus 274 and a quarter x's. When you multiply them by 0, the whole lot disappears. That is your y-intercept. Nonetheless, in a test, when you're demonstrating your skill, I think it's good sometimes to show this line. I wouldn't necessarily show the middle one, but I would write this to show that I've substituted x equals 0, got this result, and then I would draw a conclusion. I would say, therefore, the intercept, or the y-intercept, equals, and I like to give it a letter. I like to call it I, and the x value is 0, we already knew that, and the y value is minus 3. And if I go across to my graph, I go to 0, minus 3, and I put a blob there, a little mark on it, and I can put a capital I next to it so that whoever is following my work can see capital I, look through the notes and say, ah, now I understand where they got it from. That's the first of the 4 points, or the 4 bits of information. Now the second one are what we call the x-intercepts, or the roots. I'm going to write roots because it's a little bit faster. You might write x-intercepts or roots or zeros, whichever you prefer. How do we find them? Well, they're where the parabola cuts this axis. And what's the equation for that axis? Well, you might have already guessed, or you might already know, because the x value grows, 1, 2, 3, 4, and x is minus 1, minus 2. That's unpredictable, but the y value everywhere here is 0. Because we have not gone up or down the y-axis. Everything here is level with 0 on the y-axis. So guess what? To find the roots, we substitute y equals 0. Well, these 2 steps are pretty easy to understand, aren't they? To find the y-intercepts, we substitute this. To find the roots, we substitute this. Let's have a look. The way I get my students to set it out, I like the equal signs lined up. We write out the formula, x squared plus 2x minus 3, and I put equals 0 at the roots. And then I solve this equation. Now I put equals 0 because y equals 0, I could have substituted 0 here. I find it easier over here because I like to have my x values on the left hand side of the equal sign. How do we solve this? Now, in time you're going to learn 3 very good methods for finding them. But the method we're going to use here is called factorizing, because I chose a quadratic equation that we can factorize. I'm not going to discuss that right now. I'm just going to show you the principle, but in future videos I'll show you how to factorize quadratic equations. Suffice to say, this works out to be x plus 3 times x minus 1. If you know how to multiply these binomial products, x times x gives us our x squared, and we get an x times minus 1 is a minus x, plus 3x gives us the 2x, and 3 times minus 1 gives us minus 3. Why does this work? Well, now we have 2 things multiplied to make 0, and I normally ask my students to offer me pairs of numbers that multiply to make 0, and the more you think about it, the more you realise that it doesn't matter what one of the numbers is, but one of them always has to be 0. Now if this is 0, if I want x plus 3 to be worth 0, then x has to be worth minus 3. Minus 3 plus 3 makes that a 0, which, by the way, is the reason why these are often called zeros. And to make this 0, x would be worth 1. So I would write a summary. Therefore, the roots are at, and I call them R1 and R2. Now, I guess most of you have grown up in the era of bananas in pyjamas, so you understand B1, B2 and such like. We call them R1, R2. The little 1 we write just below the line, and it's called a subscript. Sub meaning underneath and script meaning to write. So these little subscripts, 1, R1, the first root will be at minus 3 and y equals 0, and the second root will be at 1 and 0. Let's plot those. This is our second part of our analysis. First root is at minus 3, and I'll put an R1 there, and our second root is at 1, 0, and I'll put an R2 here. Now it doesn't matter which way we call them, R1, R2, not really, as long as we have both those roots. Good. Obviously on this whiteboard I lack the room to show you the next 2 steps. So I'll erase this and then we'll continue with the next 2. And in future videos I'm going to show you how to factorise, how to find roots in different ways, etc., etc. But for the moment, I'm just taking you through the 4 steps to find the 4 aspects of a parabola that we like to know about. So let's have a look at the next step. Now, before we go to the 3rd step, I just realised that we sneaked past something of importance, and that was that you just saw the 3rd form of the quadratic equation that we need to properly analyse parabolas. In the previous video, I talked about the completed square form. We used that to find the vertex. Here we saw the general form, which was excellent to find the y-intercept. And what we found in this next step, where we looked at the roots, was we factorised and we formed what's called the factorised form of the quadratic. And that's brilliant for finding the roots. And we're going to use these 3 forms over and over, and I'll discuss them in much greater detail in future videos. And I'll even summarise them in one video as well. I just can't do everything at once. Let's continue with our journey and look at the 3rd and 4th aspects of a parabola that we need to know. What's the 3rd aspect? Well, it's to find the axis. Now, remember that a parabola is symmetrical, or has symmetry about an axis. Where do we find it? There are actually 3 good ways of finding it, but if you have found the roots, and here we have a root at +1 and a root at -3, if you've already found the roots and you know that the graph has symmetry, then the axis must be exactly halfway between the roots. Now here you can see it quite easily because you can count the positions on the x-axis. But I need to talk about a principle, because what if the roots were at -2 and +17, or +83 and -42 or something horrible, or even worse, if they involved fractions or what are sometimes called either surds or radicals, irrational numbers. How do you find the halfway point between 2 numbers? Well, this is how you do it. It's called the average of, I should have got rid of that as well, average of the roots. So there's my 3rd heading. We're going to find the axis, and that's how we're going to find it this time. And when I create a video later, I'll be explaining the 3 different ways of finding an axis. But for the moment, it's very, very easy here. The axis is going to be in a vertical line cutting the x-axis, and its position is going to be the average of -3 and +1. Now, -3 +1 is -2, so it's at the position -1. And I'm going to draw it here in red. And label it x equals -1. I can even write the word axis on it. And that's the 3rd task. What's the 4th one? You might remember it was to find the vertex. Now, on our parabola, the vertex will lie on the axis. It always does. Because of the symmetry, the parabola bends upwards away from the vertex on both sides, and the vertex lies exactly on the axis. So that's how we're going to find it. The x value at the vertex has to be -1, because it lies on that x equals -1 line. How do we find the y value? Well, we have a formula that tells us the y value when we know the x value, and that's our original quadratic equation. So let's write it down, and we're going to substitute x equals -1. So there's -1 squared plus 2 lots of -1 minus 3. -1 squared, of course, is -1 times -1. 1 times 1 is 1, and 2 minuses make it +1. 2 times -1 is -2. And that's -5, so 1 take away 5 is -4. Therefore, I suppose we could have written therefore axis is as a summary there, but we're going to write as therefore the vertex is at, and I like to give it the letter V for obvious reasons, V for vertex. The x value is -1 and the y value is -4. And if we locate that, there's x equals -1 and down to -4 on the y-axis, and there's my capital V for vertex. And you now see, I should have had that point in red, you now see that we have our y-intercept here, the letter I, we have our roots at R1 and R2, we have our axis and our vertex. We actually get an extra point for free, a fifth point, because the parabola is symmetrical, there has to be a point over here matching this one. And since this is 1 unit to the right of this axis, we can come 1 unit back below -2 to here. So we don't even have to calculate that one. And there's our parabola. Now, of course, I can't turn the whiteboard. I like to get in a position where my hand can move freely. So I'll just do the best I can here. Remembering to keep a rounded tip. And there's our parabola. That is a picture of this quadratic equation. Now, that's all I wanted to share with you in this video. The 4 steps that we find the y-intercept, the roots, the axis, the vertex. There are methods for finding all of those, and I'll be taking you through those over the next few videos. But I encourage you, when you get a quadratic equation, to learn the procedure and to set your work out with clear headings. Or if you don't wish to use headings, at least leave a line between each little parcel of work so that it's logical and it's clear and you follow a step-by-step procedure. And you won't basically go wrong. I'll leave it at that. Please leave your comments if you have any. I'd love you to like the video, and please subscribe. Just click on the subscribe button so that you can find out about the future videos as they appear. And thank you very much for watching.